taking this data that's in our data logs, that's recorded by these autopilots, that's the unique characteristic of a drone, and then inserting that data into the metadata fields of the photographs, so that the software can now be guided to stitch it together exactly right, avoiding not only the stitching problems with the statistical overlap, but also the distortions, both optical and positional, of an aircraft being moving around and taking pictures from different angles. So that is that's the big opportunity. If we get this right, you know, something like this, you know, the experience that we imagine is that something like this will just be a regular bit of farm equipment. Now maybe it'll be a different kind of airplane. We use a fixed wing because they're very robust. We use foam because it won't hurt anybody if it hits it. It propellers in the back. Very, you know, you can land in the grass and it won't do any damage. And it's probably going to be launched by a catapult with either a foot pedal or some little triggers, just a little bungee cord. It's pretty easy to pack. We have folding ones as well. Inside it is everything you need, the camera and the autopilot. It will probably communicate when it lands. It'll do its little pattern. When it lands, it'll send its imagery over Wi-Fi to a computer. It will then be uploaded to the cloud, stitched together, analyzed. The farmer can walk past this in the morning on the way to breakfast, step on the pedal, and have a crop survey by the time breakfast is over. That science fiction vision you saw with Uber, you know, seemed crazy, and yet there's no reason we can't be doing it right now. And the question is, how will this change agriculture? What will farmers do differently? I just want to finish with I've got 2-3 minutes. The one thing we've learned as we've asked this question, gone to farms, that every crop is different. Tomatoes and lettuce and wheat and corn, and tomato farmers might want a ripeness index with pixel analysis of the red dots and how big they are and how red they are. Some of them want infrared, some of them want video, some of them want stills, some of them want edge detection of gopher holes. You know, some of them want it different. They want to say, what does today look like compared to last week? You know, some of them want to be able to do it in real time and sort of say, I see the problem, now let me zoom in and see it from a different angle. Sometimes they want to be done by a consultant who comes in rather than walks the field, flies the field, and then afterwards the farmer is guided by the GPS. They go out and they then walk to that specific spot where the problem is, and they look at it close up. Some of them may be using it to actually guide the robotic farm machinery, like the threshers and tractors that are ultimately going to plant the field and harvest the crops. But you know, all of those things are different for every single crop. And I think that, you know, what we're going to see over the next decade is farmer after farmer asking the question: if I could have big data on my farm, if I could know what was going on, what would I do differently? What questions would I ask? What data would I need? And how do I use less chemicals and grow more food? So that's a quick overview of what we're doing, and I think I've just got a few minutes now for questions. Yes, sir, in the back.